In this video, we're going to learn about bearing. Well, what is it? Well, bearing is an important concept in navigation, and there are really two methods to express bearing, which is pretty much your location with respect to a north-south pole. So in method number one, you're given an angle, say in our first example, we're given an angle of 214 degrees. Well, bearing such as that, it's understood that the bearing is measured in a clockwise direction from the north position. So if we draw a set of coordinate axes and we use this to locate our position, to a bearing of 214 degrees, and let's mark north, south, east, west, a bearing of 214 degrees, it always starts from our north, okay, and we go in a clockwise direction, which is totally against anything that we've used before or understood before. All of our angles in standard position, if you had a positive angle, always went counterclockwise. But for navigation, bearing starts at our north pole and goes in a clockwise direction. So 214 degrees would be, this is a little bit more than 180, so we are somewhere right around here. Our angle would end up right here. Okay, so if we were flying in a plane, we would be flying along this vector here. If we were sailing in a ship, we would be sailing along that vector there. Okay, so we would end up in the third quadrant of our coordinate plane. How about a bearing of 76 degrees? Again, bearing means in the first method that we start from our north pole. So let's draw coordinate axes again. North, south, east, west. We start from our north pole and we rotate in a clockwise direction, 76 degrees, so we will end up here, and whatever we were sailing or flying, we'll be sailing or flying along this trajectory, this vector right here. Now how about the second method for representing bearing? Well, in the second method, you always start with a north-south line, and then it uses an acute angle to show the direction in either direction, either west of that north-south line or east of that north-south line. So let's start with our first example. Okay, so we are told that we're going to start off north, and that's what this N says, north. And then we are going to rotate in an easterly direction. That's what the second letter means. So we're starting north and we're going to rotate in an easterly direction, so that'll be clockwise, 28 degrees. So we will be right about here. And if we were a ship or we were an airplane, we would be flying along this direction right here. So how about if we do the second example using north and west? So we're going to start off in a northerly direction on our north pole, and instead of rotating in an easterly direction, we are going to rotate from our north pole towards the west, so this would be a counterclockwise rotation of 46 degrees. So we would end up somewhere along this trajectory right here. Okay, so how about if we started off on the south pole? In this example, our first letter here means that we're going to start out from a southerly direction, and we're going to start out from the south, and we're going to rotate in an easterly direction, 56 degrees, and so that would be a counterclockwise rotation, and we'd end up right about here. So if you were a plane or a ship, you would be flying along this vector here. And our last example is south, 13 degrees west. So again, we're going to draw in our north-south pole, east and west. Forgot to label that in the other example. North and south. Okay, and this one calls for starting on our south pole, and now we're going to rotate in a westerly direction, so that would be clockwise, only 13 degrees. So something like this. 13 degrees right there. Okay, so that vector represents 13 degrees, well, south, 13 degrees west. And that's how you would read it. You would say a bearing of south 13 degrees west, or a bearing of south 56 degrees east, or a bearing of north 46 degrees west, and so on. And those are the two methods of representing bearing. So on our homework problems, we'll need that to help us solve some of these problems.